Ladies and gentlemen, we would like to have the next lecture. The speaker is Mr. Tetsuya Hirota. He is the CPO of Dogrun Incorporated, and he is also the CTO. He is engaged in bioinformatics database development, developing application using deep learning. He is also, as a volunteer, teaching programming courses mainly for children. Today, his title is High-Speed Parsing, Massive XML in Ruby. Mr. Hirota, could you please go ahead? Thank you very much. I am Hirota. I'm very happy to be here. So there are a lot of technical discussion, and I also would like to talk some technical issue. And this is English slide, but I would like to speak in the Japanese language. So my title is High-Speed Parsing Massive XML in Ruby. Let me introduce myself. My name is Tetsuya Hirota. I'm serving as the CTO at Dogrun Inc. The company is located in Shizuoka. My main responsibility was already mentioned by Ishihara-san, like bioinformatics database development, and also developing application using deep learning, and also teaching at programming courses for children as a volunteer. And I already talked about that in this conference in the past occasion. Okay. This is Dogrun's expertise. Let me share with you what we are good at. When we say database, the life science database is what we are excellent at. And also raw data of life sciences can be converted, and also tools for visualization, and that's what we do in our company. Today, I would like to talk about high-speed parsing massive XML as part of bioinformatics database development. And this is a project we are working on, and I would like to share with you our results so far. This is a big project, and we have a huge database, and this is a bio project which we are working on right now. So in the bio or life science, like genomic analysis or RNA data, which is related to COVID-19 vaccination, and such database actually accumulated, and that's available as a public database. And bio project is actually can be found in them. Just sequence information is not good enough. So experimental data, where that study was done and who did, what kind of papers do we have, all that related metadata is necessary. In this bio project, this is not a sequential sequence information, but part of public database we have. And I'm not a specialist in the bioscience. I'm a specialist in system development. For 20 years or 30 years, a lot of know-how has been accumulated. Once it was started with XML, therefore, bio project data has been accumulated with XML. And it's getting huge, as it's mentioned here. One file is as large as 2 gigabytes. That means it's very difficult to handle, as you can see in the problems. So the bio project is offered by the site. Just a limited search patterns available. When you want to do the complex searches, XML takes too much time. So that is a problem. Therefore, in order to have a better use of XML, we try to do something about it. Then, when we want to do the parsing using Ruby, with XML, we just tried. In this case, we have another database, and bioproject XML was extracted as JSON, like one line is for one JSON. So that is a file of the multiple number of JSON. The Ruby standard is ReXML. Then the frozen somewhere and no response after all. It's 2 gigabyte, so it's too huge. And I think you often use Nokogiri. We tried Nokogiri, and it took 35 minutes. And it used more than 10 gigabyte of memory, but it's completed within 35 minutes. But when we want to keep 2 gigabyte on memory, we try to do the expert search, but it's very slow. We had a request for implementation request. We had a kind of work of Python sample. It's so-called iter path method can be used. It took only 8 minutes or so. 8 minutes, 13 seconds in my PC, very short. It is because each element, there's a tag. Each element in the first layer is lazily loaded. So it does not eat up too much memory, and it was so quick. Then we wanted to make something like a iter path. We tried to find one, but there's nothing like that in Ruby. We decided to develop one. So that is the story I would like to share with you today. In making this, there are 3 stages we have to think about. Number 1 is the first layer. So first layer element and latent reading. Then each time for each element can be passed. Then results element is actually brought into JSON-L. Output extracted JSON-L. As to the first part, the latent reading by first layer item. So in this case, we can call it enum path because it's Ruby. So that's what we call enum path. In making that, so first, the moderate operation, we try to read it. But with the moderate source, tag name, slash, and slash tag name, so it was very slow for ordinary the operation. It took very long. We tried to find out a better method, like a so-called SAX specification, which is a conventional method in XML. So we tried to use SAX. So you may ask what SAX is. So SAX is different from DOM. In DOM, you can find out the tag name at random. SAX is different. SAX, sequentially, it can read when tag or attributes are found, then event is raised, and you can do something with the event. It's such an API. We decided to use it, and Nokogiri has SAX already incorporated, so we try to do that. Then in the first layer element, with SAX, it took 13 minutes as it's shown here. So output of JSON-L to that level, it took 13 rows. So this is probably acceptable. Python 8 minutes, and in this case 30 minutes. We thought it's acceptable, but we wanted to accelerate the speed because it's only 8 minutes using Python. So parsing part should be expedited. So we always use Nokogiri for XML, but there's another library called Ox. It seems very fast. So it's very difficult to see. You can see the table. It's very fast. We tried. As it mentioned here, about 8 minutes. So within 8 minutes, we could do that. So it is the same speed as the Python sample. But we should not be self-conceited at this level. So we wanted to try a little more. In Ruby, the character, we know the character. So with parallel processing, CPU will be necessary, but it's fast. So e-numbers plus nokogiri and character was used, and this with this pattern. Nokogiri, when we actually used character instead of nokogiri for certain part, it actually didn't work. So only in the main thread, parsing was done, and then XPath was used to get a value. That's what main thread done. And JSON portion was used with Raptor. Then JSON output took time, but 7 minutes and hour. So it was very fast. That was our impression. So if you use Nokogiri with this configuration, so I think you can get a high speed or higher than Python sample. But I remember that Ox was fast, so we wanted to try more with Ox. So enum plus Ox plus Raptor. So when we stick to the speed, in such a case, Ox could be integrated in Raptor. So the reading part was in main thread, and that's passed to the Raptor, and parsing and output by Raptor without the parallel processing. It took 6 minutes. Of course, CPU usage was increasing, but it was very fast. We thought that Sax portion can be replaced with Ox. We wanted to try more, and we actually did. However, Sax inside Ox was not speedy. It took more than 8 minutes, so we gave up this plan. Then, what is the best idea? So I think Nokogiri is preferred by many users. But if it's large, then it's very difficult to install Nokogiri due to gem dependencies. Therefore, libxml Sax version can be used, and I created enum path using libxml Sax version. Of course, libxml and Ox and JSON, and that can be done parallel using Raptor, and the time was fastest, like 5 minutes 34 seconds. It was fastest. So if you don't use Nokogiri and you are focusing on high speed, probably you'd better use this method. So we have gem including all this information, and libxml version I didn't have enough time and have not shared this. And not so many people may use a massive XML, but if you use it, you can probably think about this kind of option. Today, my time is very limited, like 15 minutes. So I actually rushed, and I only could talk about just the highlight area. But for the details, as other people mentioned that the Ruby conference Taiwan, I have another opportunity to speak more. So if you have a question, could you please ask me there? Thank you very much. I could finish within time. Thank you. Mr. Hirota, thank you very much. Because of time constraint, there's no question and answer session from the floor. So if you want to ask a question, could you please contact him individually? So could you please give big hands to Mr. Hirota once again? Thank you.
No The next speaker is Mr. Mu Phantom with 5x Ruby Company Limited. Please wait for a few minutes until we set the stage.